I'll show you how to write an optimization model, how to solve an optimization problem. I'll do it using SAS. We have SAS procs using which we can solve uh, an optimization problem. I'll take an example for this. A container manufacturing company wants to optimize on the surface area of the container. The volume has to remain same. The volume is 54 pi. So the company wants that the surface area is minimized. And so the volume of the container is 54 pi, that is given to us. So what is the formula for surface area of a cylinder? It's 2 pi r square plus 2 pi r h. So r is the radius of its base and h is the height of the cylinder. 2 pi r square covers the surface area for the two the square part, the sorry, no, not the square part, the circular portion of the cylinder, the base as well as the top, and 2 pi r h is the surface area of the side part of the cylinder. So when you combine them, you get the total surface area. So we need to ensure that this surface area is minimized for a given r and h. What are the constraints? The constraints are radius has to be greater than 0, height has to be greater than 0. They cannot be negative numbers, right? And then volume is 54 pi. So this is a precondition that the volume is 54 pi. So given this volume, which values of r and h minimizes the surface area? So that's the problem for us. We'll solve this problem by using uh, a proc known as Proc Opt Model. So how do we do that? We'll write Proc Opt Model. So Proc Opt Model is a SAS proc using which we can solve optimization problems. First you have to define your variables. We are interested in r and h, radius and height. And then you define your optimization function. And what do you want to do with it? Whether you want to minimize it or maximize it. As we have already seen that the company wants us to minimize the surface area. So it's a minimization problem. Okay, in case in sometimes you will have a maximization problem. So we write minimum mean of area. We'll give it a name. It's area. So what is area? Area is nothing but r into r square plus r into h. So you might wonder that why have I omitted 2? Like the surface area is 2 pi r square and 2 pi rh, right? So why have I omitted 2 pi from both the terms? Well, in optimization, you don't need to write the constant ones, because that is not going to make any difference. So you may use it or may not use it in the function. It doesn't make any difference to your answers. So I have knowingly omitted the numeric terms. Okay, so I'm not writing 2 pi r square plus 2 pi rh. 2 pi is something that is omitted. So what are my constraint? My radius has to be greater than equal to 0, and my h also has to be greater than equal to 0, and the volume has to be the given volume 54 pi. So so I'm missing out something, con. So con says that it's a constant expression. The third constraint is the volume has to be 54 pi. So pi r square is the volume, right? So r into r into h has to be 54. Remember pi r square h. That means if I write 3.14 into this much and again 354 pi, volume is 354 pi, remember. So pi gets cancelled. So your 3.14 gets cancelled because this is the volume given to us. The volume is 54 pi, okay, and the volume is pi r square h. So pi gets cancelled from both sides. So what we remain with is uh, r square h should be equal to 54. So these are my three constraints. This is my objective function. So objective function is nothing but the function which we minimize or maximize. So in this case we are minimizing. There will be places where we would be maximizing. And what are the variables we are interested in? R and H, radius and height. And then we'll write solve. So when we write solve, it will solve it for us. And then what do we want? We want to print R and H. Once you are done, just quit from the module, optimization module. Look at the syntax carefully. Optimization syntax follows three steps. You define your variables of interest for which you want to know the values. You define your optimization function, and then you define your constraint, and then you solve it and print the variables of interest. Let's run this. Yeah, it ran fine. So the first thing that you need to see is that the log 1. You can see it says that it's converts. So your optimization is convert. There will be cases where it's not convert. That means the solution that you are getting is not the optimal solution. It could be one of the solution, but it's definitely not the optimal solution. But here it says that it's converts. That means our answers will be optimal in nature. So how many steps iteration it took for us to get to these values? You have given the iteration. So there are 45 iterations that SAS took to solve this problem. And then we go to the result and let's see what is there in the result. Well, they will have lot of statistics. Few important statistic I will discuss here. So what is the objective value? I mean the objective function value for which we found out the solution, that is 27 point something. Okay, and then what is the solution status? Whether it's a suboptimal or optimal solution? It says that it's optimal solution. That means the algorithm has converged. So it's the best solution that we can find for this problem. And what are the R and H for which the surface area is minimized? I can see R is 3, H is 6. So for radius is 3 and height equal to 6, the surface area is minimized for a volume of 54 pi r. So this is how you solve an optimization problem in SAS. Of course, you can use Proc IML to solve this problem. You can use Proc IML for optimization purpose as well. I'll discuss that in another video. This is a very introductory, very simple, optimization problem. You will have very complicated problems in reality, and you can always use Proc Opt Model and the different features of Proc Opt Model to solve such problems.